So thanks a lot. Yeah, I'm an assistant professor at the Vrije Universiteit in Amsterdam. And today I will tell you a little bit about this preliminary work, which is basically an experimental plan to measure the role of diversity in threat analysis and risk assessment. So first, a few words about threat analysis and what it is basically. So security threat analysis and risk assessment. These are approaches that are used at the beginning of software development lifecycle to identify and mitigate security risks. So this is at the time where the software is not built yet. So there is just basically a design. The downside of these techniques is they're very hard to automate. And this is something that I also actually worked on during my PhD. So I can talk about it a lot, but let's leave it at that for now. And what makes matters worse is that in many engineering domains, there is really a lack of security experts. So organizations are still ramping up the practices that and the amount of threat analysis that needs to be performed. For example, in a recent study, the BSIM survey reports from 128 organizations that they are actually going to increase threat analysis performing threat analysis by 65%. But the problem is this is still the same number of people that are having to do this manual work. There's also reports of a huge gap in the cybersecurity industry, in the cybersecurity workforce. So that's also in the United States and also in the EU, you can observe the similar numbers. For numbers, please, we'll look at the paper, not to waste too much time. So our study is based on the key observation that security workforce is not diverse, but it could be. And this paper is presenting an experimental plan for measuring the diversity aspects, but also the human factors that come into play so that we understand this better. So the contributions are that we identified 3 challenges that we're going to work on first. These are how to measure the evidence of biased judgment in this kind of context, how to also measure the actual effect of diversity on the outcomes, and then finally to identify the countermeasures that we can put into place to balance these effects. And this is with respect to industry, but also we have to think about hopefully we can also rethink a little about the education that we offer to people. So I will focus a bit less on the third challenge in the interest of time. And so I will present mainly the 2 plans, which is the survey experiment for bias judgment and the controlled experiments to measure the outcomes effect. We're also interested to understand whether there is an interplay and what kind of interplay is between the biased judgment and the actual effect on the outcomes, because we may find that there is no difference in the outcomes that are produced. However, there is evidence of bias, or vice versa, that there is no evidence of bias. However, we see a difference in the outcomes. So to say a few words about the first challenge, which is to capture the whether diversity dimensions have an effect on the bias judgment. So during these threat analysis sessions, you can imagine that this really happens in companies in this kind of context, that there is a group of experts that sit in a room and they discuss a particular architecture. And so during this analysis, there are risk decisions that must be made in face of some uncertainties for which the people in the room don't have enough statistical bias. So there is always, by definition, a room for subjective judgment. In fact, the problem is that also due to a lack of formal notations and due to different issues, let's say, there is also the technical quality of the analysis, which is ultimately determined as well by expert judgment. So measuring such bias is quite relevant because there is often a situation where in practice, there must be a preferential choice that is made between an analysis which is conducted by a group of people or even individuals. And we want to understand whether there is bias in the way that people make these decisions. So how do we, let's say, attempt to measure this? So to observe this, we plan to measure the type of bias. So in this particular study, we're only measuring gender and education bias. And the amount of biases that the analysts may be projecting when they're making certain judgments about some other people's work. So we're interested to observe this evidence of bias judgment in studies with and also without the technical artifact. So we call it a technical artifact, but it is just an appendix where there is more technical details about the outcome of the analysis. And we're also interested to do this with two different populations. So with the computer science population and with the communication science population. And I haven't said that, but we are mainly doing this in an academic setting for the first step. So here we have, I'm going to tell you a little bit more details about the survey itself, but I want to first just point out the hypothesis that we have. So first, we will measure whether the judgment bias, so that is the type of bias, but also the size, or let's say the amount of bias, whether it's the same in the computer science population compared to the judgment that we measure in the communication science population. If we find that this is true, then we want to also investigate the equivalence between the judgment bias for the communication science population when we append a technical appendix, and also when we don't have a technical appendix. If we also find, and this is the hypothesis, that these biases will be equivalent, so we actually found equivalence in the non-technical domain, then naturally we must also find this equivalence in a technical domain. So it's interesting to investigate the equivalence of judgment bias within the computer science once we give the artifact and once we don't give the artifact, and we measure whether they're equivalent. If we find that they're not equivalent, we need to understand how they differ. So for example, if the bias is greater when there is the technical artifact present compared to when it's not, then we might have actually a problem. So this might actually be a sign of systemic bias in computer science community. But this is all the hypothesis. So in the next slide, I want to just say a few words about the concrete measures. So we've heard actually in the keynote, we also heard about the vignettes. So this is basically what we're also going to do. So we're going to set up the survey experiment with bachelor students. And we have the vignettes, which is this kind of scenario that was also presented, where we vary different variables. So in this case, we vary the name of the analyst that has done some analysis, and then the seniority and the mitigation. And what's important to note is that we are also using, for this case, we're using a more high-level scenario, so that it's also accessible to the communication science students, of course. And we actually take it from the ACM ethics case study. So the link is on the slide. And now what happens is that when the participants lands on the survey page, they will get randomly generated the vignette, so a story. And then when we collect all the data, we can try to actually find out if there are certain correlations, for example, between the gender and the consistently chosen preference to one of the analysts, one of the profiles of the analyst. So now I'll spend a few minutes talking about the second challenge as well. So the second challenge is to measure whether diversity dimensions have an effect on the outcomes of the analysis. So here, to motivate this further, I will only take as an example the gender dimension, but there are, of course, other dimensions as well that we can observe. So whether if gender is an actual factor in the outcomes. I want to mention two studies to illustrate how this can be from different disciplines. There can be slightly contradicting results. So a recent study in the risk analysis space investigated the risk homeostasis theory in the context of cybersecurity risk. So in a nutshell, this theory says that humans tend to maintain a balance between the perceived risk and the target risk. And they modify their actions accordingly so that they equalize the risk. So for instance, users of antivirus software may actually behave in riskier ways because they feel protected by the antivirus software. So they correct their behavior. They found evidence of this, but it's interesting also that they found that gender was one of the significant variables for the impact of security event awareness. But we don't know why exactly, and they also didn't investigate it further. So in addition to that, the actual artifact of measure here is not technically very complicated. So we're talking about opening an email attachment or not. So let's look at the technical domain. There was also recently an interesting work that they had a study with 80 practitioners in the software engineering domain, and they actually found that female practitioners with combined intuition and rationality, they designed more novel software features compared to men. So it's interesting that there are actually contrasting results coming from different disciplines. And it's also interesting that this hasn't yet been investigated in the context of security threat analysis, or let's say security engineering in general. So to test the hypothesis that I show on the slide, we aim to have controlled experiments, and this is only within the computer science, so only with computer science students, because we actually need to, actually the task is to conduct an analysis, right? So we have these following 3 hypotheses, and concretely we've done this before also in the past, and what we do is we have documentation of a software system that we hand out to the students. Then we have a training session with them where we train them on the technique that they need to use, but we also train them on the background that they need for the case study, basically. And then optionally, we can have the diversity training, but this is something that I will say a few words after. And after the training, they actually have to perform the technique, and they report the outcomes, which are the identified security threats that are prioritized, perhaps also the mitigations to the threats. And these outcomes we measure. So a few words about the hypothesis that we have here. So basically, we don't really expect that the outcome types will differ when it comes to gender. Despite the studies that I've highlighted before about risk, that they have found some differences, we don't really have reason to believe that in the technical domain, there would be a difference. When it comes to different background in education, we do have probably some variance in the specialization tracks that the students have, but it's actually still a computer science, so we don't really expect to have large differences there. And then finally, when it comes to the nationality, we don't expect we expect statistically equivalent outcome types and quality. We haven't found any research that would suggest otherwise. So the findings of this hypothesis will actually play a key role in identifying the countermeasures that I kind of mentioned, but I didn't really go into so deeply. As you could think about having diversity training as a first step to try to develop it and try to see in the companies whether this helps. But in addition to that, I think that, I personally also would like to really work towards increasing the number of diverse students in security, courses that have a security component. So this is still very much a long-term plan. And so I think I'm at the end. So finally, just to conclude, I presented these 3 challenges that haven't been explored efficiently. I also presented the initial plan for 2 types of studies that were actually ongoing work. And yes, of course, I'm very motivated to conduct this research. And despite that, there are potential limitations, which I haven't mentioned, but I think they were also mentioned before. For instance, yes, the inevitable small female population and the generalizability in general, this kind of academic context to the industry. So thank you very much for your attention, and I'm happy to receive any questions.
So I want to thank you, Katja, and as I wrote in the chat, this is an invitation for you, but also for all the other people. Join our network eugain.eu, because we are exactly looking for people like you who plan to do these wonderful studies and want to connect to the international community so that we do more together. So Katja, I'm looking for now. I would like to talk to you a lot, but I am very glad.
I think I already joined, actually. I'm in one of the working groups.
Nice.
So I think very